Up next, David, I think you're introducing the next talk.
Sure, why not? Tom, man behind the curtain, do you want to bring in Spencer and Jim from Cockroach Labs? I see we have Jim. Hey, Jim, how are you?
Hello, guys. How are you?
We're doing very well today, thanks. Where are you beaming in from today?
I am in lovely, sunny Denver, Colorado today. So after the COVID chaos, I moved from New York out into, some sunshine and some mountains. It's beautiful out here.
I'm only mildly jealous. I am in Glasgow in Scotland, so I am currently staring out a window at black clouds and rain. Fantastic. Hey, Spencer, how are you?
Hey, how's it going? I'm doing well, thanks.
And where are you beaming in from today?
I'm in the Dominican Republic at the moment.
All right.
It just makes it worse for you.
Again, I'm sitting here in rainy Scotland. Thanks for making me feel so wonderful today. No, seriously, awesome to have you with us today. We have some random questions. I'll throw that at you. Mark, do you want to say anything before I go?
No, if you get me talking with Jim, we'll never get the talk done. So
that's true, Mark.
Leave it for the end.
It's too early for pints too, Mark. So let's just not start.
Well, maybe not in the Dominican Republic, but anyway. So, random question we have for all of our speakers today. We've tailored this one just for you. We know that CockroachDB is designed to survive any disaster. So let's say you're the last man on Earth. What one thing do you need to survive with you? I'll pass that to Jim first.
Oh, come on, man. I'll take the Homer question and just say, I just need an endpoint. That's it. How's that?
That's fine. Spencer, what about you?
I think a Kindle loaded up with my entire reading list that I've accumulated over the years.
If that was me, I'd have the Kindle and still be looking at it saying I don't have time to read, but that's my own fault. All right, well, thank you for joining us today. Please share your screen and take it away.
All right, thanks, guys. We're not going to share slides or anything. We're going to do a quick chat. Honestly, I first met Spencer. God, Spencer, the first time I actually saw you was on stage with Alex Bolvey at, I think it was OpenStack Summit. And you guys were showing a database that we couldn't kill on something that was called Kubernetes. Do you remember this way back? It was,
of course I do.
Yeah, you had like 11 people on stage, right?
It's CoreOS. Well, so there was CoreOS Fest, and then there was the, I guess the huge OpenShift
Right.
conference where we actually had maybe like 17 different participants, all with different private clouds, and all of them spun up Cockroach nodes, which connected into a single giant cluster.
Right.
So that was pretty amazing, just in terms of watching Kubernetes be able to orchestrate that many different participants all into a single database.
Right. And that was, I think, about 4 years ago or so, honestly. And so I think we've come a long way since then about, living data on top of Kubernetes. Are you still there? Yeah, okay. I thought you just stopped for a second, the video. So, but let's go back a little bit further before this. And, I bring up Polvy and I bring up that moment because that was the very beginning of me really actually understanding GIFEE. And the theme of today is, Google infrastructure for everyone else. And I think, what Polvy and Phyllis were doing at CoreOS, and led by, I think, Mel Smolensky, who's going to be on later today here in this conference, really pushing that as a concept. It's applicable, and I think we're seeing it play out in a lot of companies. But in order to get to that, I love to have a Google engineer on here because that's where this all started, right? And so, Spencer, just give me a quick lineage. When did you start at Google?
I started in 2002, and actually that was right when my two co-founders of Cockroach Labs also started at Google. And I'd met Peter before. He was actually the reason I went to Google. But Ben was just graduated from University of North Carolina, I believe. Right. And he got put onto a team with me, and we actually started building Java infrastructure at Google. And Pete was working on Gmail and also was doing some of the Java stuff as well for their front end, and he wrote sort of the back end to that. So we all kind of got our start together working on overlapping projects.
Right, and I think you guys were all in the mid 300s in terms of employee numbers. I think it was like 150,000 people now. So
yeah, it was in the mid 300s.
And what were you working on, Spencer? Early days.
Early days, Java infrastructure. So Pete actually kicked off the Google Servlet engine, which was an alternative to Tomcat that worked more like Google binaries that were run on the C++ side. So So it was really just a single jar file, which it sort of packaged up all the dependencies and made it so that you could deploy the Java applications with a very similar set of monitoring tools that were being used to run the C++ application. So that was one of the first things that we worked on, and also wrote a data persistence layer. And ultimately, actually, I got put on the AdWords project for a little bit of time. And this is when it was starting to really exponentially scale. And it was sharded MySQL, which is a very common pattern for database usage in Silicon Valley and more generally. But essentially, you're going to put some of the AdWords customers on the first shard of MySQL. And then as it grows, you don't have enough space on that. So you add another instance of MySQL and you put some of the customers on there, and so on and so forth. And the scaling of that, because it starts at 1 and then it goes to 2 and then maybe 3 or 4, then 8, then 16 and so forth. And each one of those steps actually introduced new problems, new fires. And so there was this thing called the ads war room that convened every morning, and everyone discussed the latest problems and how we were going to solve them. And it was, very fraught at times, high tension environment, but quite an incredible learning experience. And ultimately, I think much of the learning from having, say, to go from 16 shards to 32 shards, and then watching all the databases start to fall over because they had too many connections from too many application servers and so forth, that actually became an anti-pattern at Google. So the experience on the AdWords project led Google to conclude that their problems were too big for that kind of an approach, and there was too much complexity in letting the application have to comprehend the presence of many different instances of an underlying database. You couldn't do, for example, queries across them. You couldn't do transactions across shards. And then you'd start getting customers that were so big. I think eBay was an example. It's so many different campaigns and things, they couldn't even fit onto a single MySQL instance. So what you had was a spiraling problem with complexity. Yeah. Because all of this abstraction that should have been in a database that simply could scale was built now increasingly into the application layer, where many developers that simply wanted to add a new feature to the AdWords system had to contend with the fact that they had to understand that underlying all this were many instances of different actual databases, and they had to be connected to separately, and you couldn't do certain kinds of operations that would normally be natural to database.
Right. And I mean, it seems to me, Spencer, okay, so first project, let's replace Tomcat. Second project, I think you moved on to like Google File System and rebuilding that into Colossus and that whatnot. And so and I want to come back to the sharding of the database problem. Absolutely. But it comes back to, I mean, if we're talking about GIFEE and we're talking about Google infrastructure for everything, there's a little bit of a different mindset in Google also, right? Really from the early days in terms of, and kind of rebuild everything for scale is kind of one of those things, right? And it's like, so why buy or why go use something open source when you can actually invent it yourself? How was that driven? Was that just like the mindset of everybody that came in? Was it kind of like, there was some pretty amazing, I mean, I think about Jeff Dean and Sanjay Gemawat and some of the stuff, like the white papers they wrote, Spencer's pretty amazing. Like, we have like Bigtable, MapReduce, Jesus, Spanner,
GFS,
geofencing, and these guys, like it's pretty intense. And I think if anybody's listening right now doesn't know who those two are, they should go actually check them out, because it was, and I mean, geez, Eric Brewer came in, and you guys want to talk about Kubernetes and kind of the whole advent of all that stuff. I mean, there were just some really amazing minds, but like, how did that kind of go out to everybody in the team, right? I mean, you were part of that, right?
Yeah, the thing that was different about Google in 2002, and I think remained different about Google through the rest of the aughts, was just the assumption that they had of massive scale as a sort of precondition to all of their products. In 2002, AdWords was one of the first problems that was sort of outside of the problem of search. And AdWords, if you think about it, the scale is much different than search, right? You're just talking about advertisers. It's not just the average person that might be searching on Google. But even that problem became one where scale was one of the biggest considerations and the biggest challenges to overcome. But in the context of Google in 2002, as they started to add things, like they added something that allowed you to have more information about someone that was searching based on their cookie history, and that allowed you to serve them better results. And trying to wrangle that data, now something isn't just like a static index of all of the things that you might crawl on the web, which was just a fantastically large problem that required their own infrastructure from the start. They used something called, they had these, they called them index RT index. It was a real-time indexer that like allowed you to sort of layer in additional search results as it went. That started to morph into more and more read-write requirements in terms of the underlying index. And that's and so if you start with the problem of how big the index is, or even how big your AdWords population is, you start to have to consider everything from a very different perspective. And that was just that sort of was suffused all of the sort of projects at Google, and was really became part of their DNA. So that actually I think was the impetus for designing everything a little bit differently, and in fact feeling like it was necessary to do it on their own, to do the R&D on their own. And that some people describe that as hubris. I think there's an element to that, like, oh, nothing's good enough for us, we're Google, right? There was some of that, not invented here kind of thing. Yeah. But I think to be quite honest, they it worked out very much their advantage to have that perspective, because they both built the next generation of technology that's now become fairly standard in the ecosystem. But it also allowed them to maintain a very significant competitive advantage, because they simply were able to say, we're going to R&D our way around these challenges instead of having to just muck on through it. For example, using sharded MySQL, we're going to build Bigtable. Right? That was really one of the big reasons they built Bigtable. And then they said, okay, Bigtable is great. It's elastically scalable. And the AdWords team said, well, you don't have transactions. We have 500 tables, complex things. People are spending money. We need transactions. And the Bigtable team said, okay. So people went back, and only 2 years after Bigtable was released, they released Megastore, which actually introduced some transactions, but again was in the context of massive scalability as Megastore. And eventually, that was deemed to be good for lots of different new use cases, but not good enough for AdWords. And so then Spanner came along. And by the way, each one of these things, I think maybe not Megastore, but certainly Bigtable, and then Spanner, where Jeff Dean and Sanjay Gemawat, along with many other projects, those guys are pretty legendary. But Spanner eventually got to production, and then they said, okay, well, it's still not good enough for AdWords. We need to add SQL on top of Spanner, which is a project called F1. So that actually brought it all together, and they finally were able to move that AdWords project. So it was a whole decade that I was there for, that went from the sharded MySQL through many iterations of R&D around databases to Spanner and F1. And by the time they replaced AdWords, it had gone from, I guess when I started, around 2 or 3 shards or something like that, to over 1,000. And so that was able to be completely replaced by the new Spanner F1 project.
Well, and you talk about shards, you talk about management of things and this sort of thing, and it's kind of like the operational complexity of, well, Jesus, just managing the 10 people or the 40 or whatever it means to manage all those shards, let alone the cost to actually employ them, is just insane, right? And I think that's one of the things that Google, for me, when I look at kind of all the systems around scale and resilience and just how they do things, like the advent of the SRE and this whole kind of systems thinking and scripting through these problems, like we wouldn't be where we're at today without this. I want to touch back on one thing though. Not all the projects that Google did. The initial version of search was big files, and I read somewhere that somebody actually internally they called it bug files. And then they had to rewrite the whole thing, right? So
I think the joke about big file, and big file, by the way, was a way to get around the 4 gigabyte limit on file sizes. Yeah. And so it basically strung many potentially 4 gigabyte files together, 2 gigabyte or whatever it is they used, and that could create very massive petabyte sort of size things. I believe that was written by Larry or Sergey. And the joke was just well, it's a good thing they're not writing code anymore. And I kind of feel the same way now that I'm the CEO of Cockroach and don't actually do any coding. You realize I used to write code, but it's been a while.
I've seen you write code. It's good. But it's interesting too, because it took a wholly different approach. If you think about these massively scalable systems, and you think about performance, you think about scale, getting down into the registers within the CPU itself and going to that level to actually come up to provide this sort of value, I think is where, I'm inspired by a lot of the innovation that happened in the aughts. I think, I'm a child of history. I love history, and actually reading through what happened is truly phenomenal. But like I said, I think the thinking about scale is more than just the systems alone, and thinking about the people that are around it and the effect of those people that are around it, I think is one of the things that has really created the CNCF, for that matter, this whole movement towards cloud native, this entire movement. And when you left Google, Spencer, you did a couple things, and basically you were looking for Google infrastructure. So, I mean, the talk here is Google infrastructure for everybody. So what inspired you then to go out and say, I need Spanner because I have these problems, right? And I think everybody's dealing with this right now, right?
Yeah, it was actually, I needed Spanner and I needed Borg. So Borg was the precursor to Kubernetes. And probably in 2006, Borg was as sophisticated or more so than Kubernetes is in 2021. So that just gives you an idea of just how much investment Google did actually put into these early systems. We left Google and we were building a private photo sharing startup. So we in my career, and actually all my co-founders as well, we kind of hop between infrastructure and then applications and infrastructure. And you get to sort of build for your applications when you're building infrastructure, and then you get to use your infrastructure when you're building the applications. And so we were jumping specifically from infrastructure. I'd been working on Colossus for the last 5 years, which is exascale distributed file storage. And then we left to build private photo sharing. It's a very, very different sort of thing. Yes. But again, now all of a sudden we were thrown on the mercy, not of Google's infrastructure, but of the open source that existed in 2012. And it was, honestly, it was a little bit disappointing coming from what Google had already built, and Spanner in particular. You just saw, my God, Spanner just takes so many of these concerns and solves them under one holistic database architecture. And we didn't have that. So we looked into Mongo and we looked into, MySQL and Postgres, of course. Eventually we used Amazon DynamoDB, but the idea of Cockroach was born in that process. And when we really thought about Cockroach and how it needed to act like Spanner, but had to be built very differently, because at that time there wasn't Kubernetes. So we're like, okay, well, Google used Borg to schedule everything. It wasn't like they didn't have any idea that only stateless application use cases would be running on Borg, and stateful stuff was introduced later. Everything ran on Borg. So GFS was all scheduled on Borg, and of course, Bigtable and Megastore and Spanner were all scheduled on Borg. And so when we left and we were thinking about building something like Cockroach, in fact, the name actually preceded the project by quite a long stretch of time. There was this realization, we don't have something like Borg. There was no Kubernetes then. At least it was in its infancy, if there was one. And we said, okay, well, how do you actually schedule something like this and add nodes and make it all work such that an average human can do it without building incredibly complex scripts? And actually that informed how we built Cockroach. We tried to say, okay, well, this can be run by a single operator as easily as possible, and that was a big part of the design philosophy. And again, it was because of the lack of what existed in the open source ecosystem in 2012. We'd probably do things differently today. Everything would be just from the start, assuming there were Kubernetes operators, for example. But that just wasn't an assumption you could make when we started to design Cockroach.
Right, and I think it's it's played out over the past couple of years too in terms of adoption of something like Cockroach versus taking something. I always kind of think of this as like there's lift and shift, move things to the cloud. There's move and improve. Take legacy tech and kind of modify it so that it's going to work within this new environment. But this is a complete re-architecture, right? To really kind of deal with the problems of scale and resilience, which basically kind of is rooted in the very heart of what the Google team was about. That's what Google engineering is about. Like, let's really reinvent and re-architect to fit the platform, right? And I think that's the kind of key thing. So, so as you're building out and you don't have a Kubernetes, let's fast forward a couple of years now. Here we are, Kubernetes. This is KubeCon this week, right? Like, gosh, last time I was there, I don't know, tens of thousands of people there. This is insanity. It's playing out. What's the role of the database in this new world, Spencer? And it's a little bit of a Homer question. You and I think about this all the time. But I got to tell you, when I was at CoreOS, I was worried about this too, right? We had started, storage projects, right? We had Taurus or Talus or, oh my God, Mel Smolenski is going to really kill me. Distributed storage, right? And I was thinking about applications because applications need data, right? And so, what is the role today around Cockroach and kind of the database in this emerging kind of Kubernetes world?
Well, it's similar to what it's always been, right? But the database does require different operating mode in order to be efficiently run with little operator overhead as possible, using the new tools, Kubernetes being, I think first among them. There's something else that I think was realized at Google early on, which is now becoming very necessary for databases. And it has to do with a sort of it's sort of like a law, like the same kind of law as Moore's law. It's an empirically derived, sort of wisdom. And the one that was very interesting at Google that I cottoned onto early was just this idea that at scale, if there's anything that can theoretically go wrong in your model, whatever it is, let's say it's your database consistency model, it will go wrong and it will become a massive problem for you overnight. So you have to design, whether it's Colossus or GFS or Megastore or Spanner, all of them were designed so that it was very careful exactly what the guarantees were. It didn't mean that there was always the right guarantees for the application use case, but they were very well understood. And the bugs in those systems were the ones that were rooted out first and most aggressively. So for example, if you actually have transactions, if you don't make them serializable or even linearizable, then you're going to have certain classes of problems that creep in. And so Google is very careful to say, okay, we're going to make these systems bulletproof. And where they have gaps, we're going to very clearly understand them. And I think that is something that now the rest of the world is experiencing. You can't just sort of squint at something, and people call them sort of eventual consistency. There's funnier ways to describe the lack of transactions, but when you're building on a foundation that's essentially in sand. It's one thing if you're not putting very much on that foundation, but if you're putting like a skyscraper on it, you better bet it's going to fall over, and it's going to fall over rapidly. And these days, I'd say a startup has the potential to get the kind of scale that Google needed in 2002. Like absolutely, virtually any startup.
Yeah, why not build on a foundation if you're going to build a skyscraper or not? If it doesn't cost you anymore or isn't any more complex, why not just go there, right? Because honestly, Spencer, there's actually a name to what can go wrong will. There is a law, it's called Murphy's Law, honestly, right? Like, so that's just gonna happen, right? So, and I think it's true though, but I think the database to me, the database is part of infrastructure. Like, I think that's the surface area with our applications and services. Like, and if you're gonna treat infrastructure as distributed, then let's treat the entire stack, up to the application layer, which I think there's impact in the way that we code and the way that we develop and the way that we think about things in distributed systems, right? And so, what are some of the things that, the challenges with becoming a distributed mindset, which I think, again, to do GIFEE right, to give Google infrastructure, there's a mindset in terms of scale and resilience and the way you think about distributed systems that you've been in for a long time, Spencer. Me, I came to it 5 years ago, took a little longer for me to figure out, right? Like, what are the key things people should be thinking about as they kind of move towards distributed systems?
Well, it's all the sort of standard lessons, but eliminating sort of single points of failure, scaling sort of choke points in an architecture. I think that there's a huge part of this which relies on open source. These ideas being open and interoperable and maintaining or adhering to common APIs and various frameworks. There's a huge amount of synergy, I think, that is possible when there are open standards and open ideas. So I think that's a really nice aspect of today's modern stack that wasn't actually true at Google. I mean, obviously internally at Google, everyone had access to everything, but okay, that's whatever, 30,000 engineers now, or I don't know exactly what the number is, whereas there's 24 million developers around the world right now. So I do like the openness of the current ecosystem. And I think credit where credit's due. Google had a lot to do with the ideas that now have become the foundation for basically everything that companies are using to build modern stacks. But I like the current incarnation being as open source as it is. But we've had lots of discussions about where that's headed, and it's an interesting future ahead of us because while there's still plenty of private clouds and lots of open source software usage, even infrastructure, increasingly people are consuming these things as services. So that's putting pressure on the open source model, and it'll be an interesting next 10 years in terms of how that evolves.
That's right, and I can't wait for free beer to be returned to open source, right? So we'll see how that all plays out. I think the Google has done a lot for all this. I think look at the CNCF was created Kubernetes. I think this community in particular, the cloud native community, and God bless what Dan Cohn did just to start the whole thing off and saying, they aren't going to be kingmakers. Let's make this a true community where a little bit of a meritocracy lives. And I think that's kind of the stuff that happened internally at Google for years. There were some really amazing minds, and we're all living in that world now. So thanks, Spencer, for that conversation. Mark, and do you guys want to? Were there any questions or anything? I try to leave a little bit of time here. Sorry, David. Yeah.
Yeah. No. Thank you very much for that. It was great just to have you two both talking tech and trying to get a glimpse into how you think. It was very informative, very insightful. Cool. We have a few questions. I'm going to be completely selfish and throw my own out first. So you kind of caught me right at the start when you said anti-pattern for Google. And this is something I think, especially in the cloud native landscape, a lot of the conversations, back at conferences when they were actually a physical thing, is like a lot of startups and smaller teams and organizations always say, oh, that's an anti-pattern because Google said so, or this is something we have to do to scale, but not at what level of scale. What is your advice to these smaller teams and organizations that are trying to adopt these state these anti-patterns as ubiquitous fact at all levels of scale? Is avoiding them a pro or a con? I know it's quite a lot there. So
that's an interesting point, and I think it's very valid. Certainly when we started Cockroach, many people came to me and said, well, it's cool what you're doing, but I don't think we need that much scale. We're just happy using Postgres. And, listen, Postgres can scale to reasonable sizes. And so I don't think it's an anti-pattern to use Postgres. It's definitely not, or MySQL. Those are very appropriate tools for certain kinds of use cases. It became, the anti-pattern at Google was really, I think, predicated on an assumption of a certain level of scale, like petabytes of data. And at petabytes of data, MySQL and Postgres were not designed for that. And so, trying to use them, trying to work around them, essentially what you end up doing, and many companies have done this. I mean, Facebook's an incredible example. They have hundreds of thousands, maybe millions of shards of MySQL. And they've built a metadatabase using MySQL as sort of the engine of many nodes inside. And that's fine, right? But that is a huge project in its own right, probably engineering millennia. And so, certainly if you are setting out to achieve ambitions that have that kind of scale, I mean, Facebook's a pretty insane amount of scale, but even if you're trying to do like 1/100th of what Facebook is, and that's your ambition, you want to be a very valuable company and serve most of the market that you're setting out to serve, then yeah, it would be an anti-pattern to stick to a monolithic database architecture. And I think that's what Google was getting at, where they said, okay, no more sharded MySQL, but it was really no more sharded MySQL, not no more MySQL for a task that would deserve MySQL.
Yeah.
All right, thank you. We also have an audience question where they were curious about the outgrew sharded MySQL question, or your statement around that. And to phrase it slightly differently, I think what they're asking is, would Cockroach DB exist today if something like Vitesse had existed at the time you were building it out?
Well, Vitesse did exist when we built Cockroach. Yeah. And Vitesse is an interesting example because I think of it as an intermediate point in this sort of spectrum of database architectures. You've got the monolithic architecture, which is the Oracle, although of course there's Oracle RAC. I mean, there's always variations here. But Postgres, MySQL, these are monolithic. Whereas a distributed database would be something like MongoDB, or in the relational world, Cockroach or Spanner. I think the Vitesse architecture lives in between those. It's clearly distributed, but it's more like the sharded MySQL that we had originally with AdWords. In the sense that Vitesse actually was aiming to essentially create a sort of metadatabase on top of multiple MySQL instances. And so it's essentially a productized version of what was sort of custom built for the AdWords backend. So the problems with those kinds of architectures is that your actual SQL engine in any one of the individual MySQL instances can't address the larger distributed body of the whole distributed system. And you have to then build that at the higher level above. So essentially what you're doing is building a database using MySQL as a lower level engine, which is fine. But I think you can end up doing more, say for the next decade ahead of us, like into the 2030, if you start with an architecture that's distributed from the get-go, where every single part of Cockroach is capable of reasoning where necessary about the fact that there's distributed architecture, distributed data, and that actually allows us to do interesting things now around real geo-partitioning. So it really spanning continents and so forth, where geographic latencies become critical, and you want to set controls and even do different kinds of transaction models that recognize there's going to be significant geographic latency between accessing different bits of data, and that actually can suggest really interesting things that you would just never do in a monolithic architecture. And so yeah, it's like you can work from the monolithic towards distributed, which is what Vitesse is doing, or you can start distributed like Spanner and Cockroach have done. And I'm not going to say one's better than the other. They're different approaches. I think that you can make faster progress when you start from the monolithic and you move, because especially, listen, I mean, Vitesse is MySQL, right? And Aurora is Postgres or MySQL. And so you actually get that wonderful migration path, like everything works. But on the other hand, you then have some limitations about how far you can really go with it, because your architecture's got a lot of legacy stuff in it. So yeah, it's just different approaches. We decided to start from scratch because we feel like there needs to be another 10 years of what databases can do, things that we haven't even thought of yet, and owning that architecture from at every layer is actually a real advantage to achieving that goal.
Yeah, so what you're saying there is like, Cockroach DB is built to be cloud native up front. And I think this leads me on to my last question, and I'll let you both get back to your day. But, if there's one way to divide an entire room of people at KubeCon, is to throw out the question of, should I run stateful workloads on Kubernetes? Like, immediately, you just, boom, everyone they go straight to their side, and that's it. Like, they cannot be changed. Now that we have cloud native databases like Cockroach DB, what do we need to do to get more people on board with stateful workloads on Kubernetes? How do we bridge this gap and get more people involved?
It's a good question. I confess that I'm always feeling a little bit surprised by that distinction. I feel like in the Kubernetes, my understanding of it is just that this is the way Kubernetes evolved. It just didn't support stateful workloads initially, and people became comfortable with that, and in fact became, annoyed that people were asking for stateful workloads on it. And two sides, this dichotomy was created. It didn't really exist at Google, as I mentioned previously. Borg was built to handle the stateful and the stateless sides of the equation in terms of everything that needs to be deployed out there to make things work. And as I think most of us realize, there's not very many applications that don't need state. In fact, unless it's a mortgage calculator, you probably need state. And so if you have a complex distributed data storage system, whether it's Colossus or Spanner, or Cockroach, those things can be fairly difficult sometimes to deploy. And you have something very sophisticated like Kubernetes. I mean, if Kubernetes isn't going to deploy your Cockroach, then you have to have something else do it, or someone else, right? So you can pay lots of SREs to do it, or you're going to let SREs do other more interesting things and let Kubernetes do it. So I think it's just a matter of people getting more and more used to the tools, and more tools getting created, in addition to things like Cockroach. And you just realize, okay, these operators are getting really sophisticated with the stateful workloads. This is easy. I guess, I'm going to use Kubernetes for this, because why wouldn't I? I'm going to have to use something else if I don't use Kubernetes. And I suspect that dichotomy will probably heal itself over time, just as these things become more, commonplace.
Awesome. Thank you. I'm looking forward to the day we can say this is easy to run stateful workloads in Kubernetes. Thank you, Jim. Thank you, Spencer, for joining us today. That was fantastic. I'll let you get back to your day. And I think, Tom, we're going to bring in our next guests.